Welcome back. In this video, we're going to do some more trig integrals. In this situation, we're going to look at a strategy for eliminating a square root. So we have some trig identities that we know. One that we use a lot in Calculus 2 is a double angle for cosine. So cosine squared theta equals 1/2 times 1 plus cosine of 2 theta. And if I look at this double angle, I will see it looks really similar to what I have over here. I've got 1 plus cosine of some doubled value. 2x doubled is 4x. So I could also rearrange the given identity and say 2 cosine squared theta is 1 plus cosine 2 theta. Since I know that, and I have that identity, I'm going to think about doing this, and I'm going to let theta equal 2x. So that would give me 2 cosine squared of 2x equals 1 plus cosine of 2 times 2x. Or rather, 2 cosine squared 2x is 1 plus the cosine of 4x. So with the manipulation of an identity, I've achieved my radicand, the expression under my radical. And since these are both equal, I'm going to sub in under my radical 2 times cosine squared of 2x. So this integral is 0 pi over 4 times the square root of 2 cosine squared 2x dx. And you may notice, because I did a substitution, you may be thinking, well, Ms. Stein, do we need to change the bounds? And because we started in x, these were in terms of x, we are still in terms of x. No change needs to be made to our upper and lower integral bounds. Now, the square root of 2 is a constant. I'm going to pull that out in front. So here I have the square root of 2, the integral from 0 to pi over 4 of the square root of cosine squared of 2x dx. Now, you'll notice square and square root are inverse operations. Those are going to cancel each other out. I have the square root of 2 dealing with the integral from 0 to pi over 4 of the absolute value of cosine of 2x. And when we square root something that is squared, we just put those absolute value bars because we know whatever was under here had to be positive. So whatever this root is, we have to use the positive value of it because you can't take the square root of a negative number. Now, given my interval from 0 to pi over 4, and the fact that I know what my graph of cosine 2x is, we can say that since cosine 2x is positive on that interval, when my x is from 0 to pi over 4, I can get rid of these absolute value bars. So I've got the square root of 2, integral from 0 to pi over 4 of cosine of 2x dx. And this, of course, is very simple for us to integrate. Integrating cosine is going to give me sine. Because I've got that coefficient 2, I will divide by 2. So this is sine of 2x over 2, and that would need to be evaluated between pi over 4 and 0. Square root of 2 over 2, sine of 2x from pi over 4 to 0, plugging in pi over 4. I've got sine of 2 times pi over 4 minus the sine of 2 times 0. So that is root 2 over 2 times the sine of pi over 2 minus the sine of 0. Sine of 0 is 0, and sine at pi over 2 is 1. So this value equals 1. This value is 0. 1 minus 0 is just 1. And my final answer here is root 2 over 2. So that is just one of several strategies that you can use to deal with square roots. The main thing you want to note here is that I used an identity to take something that was not to a power and to turn it into a power. And the goal of that was because then my radical and my power would cancel each other out.